Hi, welcome back to Gnage Virtual Science. Today's lesson is all on absolute dating. And nope, that's not like, well, we're absolutely dating, we're going steady and we're not dating anybody else. That's not what I'm talking about. I'm talking about the scientific way that scientists can give an actual age to rocks, to objects, to fossils. And so absolute dating is giving a numerical value to the age of something in years, saying that this fossil is 650 years old. That would be giving the absolute age of it. So that is what we are going to be talking about today. Again, absolute dating, or giving the absolute age of an object. Okay, so you're a scientist, you're a paleontologist, you're out there digging up fossils, and you come across one, a bone of a mammoth from way back when. So how do you give it an absolute age? Well, there has to be a scientific way to do it in order for people to accept that numerical value, in order for people to accept that it's 40 million years old, right? So the way they do that is called radiometric dating. Sometimes you might hear it called radiometric decay. It's the same thing. And so it involves a process. Elements. There's some elements on Earth. When we talk about elements, we're talking about the periodic table. So elements like carbon and oxygen and potassium and hydrogen and helium, those are elements. Well, some elements on Earth are considered unstable, okay? And what that means is they decay or break down over time into more stable elements, okay? You might have heard of things being radioactive. Well, that's kind of what I'm talking about, but not on the levels of like, oh, dangerous radioactive stuff, okay? But basically, there are some things on Earth that will decay, some elements that will decay over time into stable elements. And that is the process that scientists use. So if you are an unstable element, some of the ones that exist are uranium is unstable, potassium 40 is unstable, thorium 232 is unstable, even carbon 14 is unstable. And so those things that are unstable, they decay at a rate, and it's the same rate. So it is always going to be uniform, okay? So they are decaying at a specific rate, okay? So let's talk about that. So these unstable elements that are decaying over time to become more stable, I mentioned they're doing it at a particular rate. That rate is called their half-life, okay? So let's think about that for a second. I have a piece of paper, okay? And let's say this is an amount of uranium, okay? This is a particular amount of uranium, and I have a good 100% of it. This is all of it, right? This is the whole thing. And let's say I decay half of it, right? If I know that it takes a certain amount of time, let's say 100 years, that's not correct, but let's say, to make it easy, it takes 100 years for half of my uranium to decay. Okay, all right. And now, if I decay another half, another 100 years has gone by. So let's decay another half. 300 years have gone by, okay? So I'm a paleontologist, I'm doing my thing, and I find a fossil. And I look at that fossil, and I no longer have this much uranium in it, not the whole amount. But what I find is this amount, okay? So if I compare this amount to this amount, I can figure out using a ratio that 3 half-lives have passed. And recall, it takes 100 years for the uranium to decay by half. So now I've got this much left. I can now calculate that 300 years have gone by. That's my example, okay? So in the gist of it, just the basics, if you know how long it takes something to decay, to become stable, and you find a sample, a rock or a fossil or an object, you find it, and you then see how much of that element is left, you can calculate how many years have gone by, okay? And that's how they do it. That's the scientific principle for giving an actual date to how old rocks or fossils are. So one term that you will see come up when you talk about absolute dating or radiometric dating is something called carbon dating. And this is a common term that scientists will use because carbon-14 to be specific, is an unstable element and it decays over time. And they have actually determined the half-life to be 5,730 years. So it takes 5,730 years for half of an amount of carbon to decay, okay? And carbon dating is common because all living things have the element carbon in it. So when you talk about dating fossils of plants or animals, they contain carbon. So most fossils of living things, okay, fossilized living things, they actually use something called carbon dating to give a numerical value for how old that fossil is. Okay, so the last thing that I wanted to talk to you all about was the fact that we mentioned on Monday at the beginning of the week that Earth has been dated back to be 4.6 billion years old. And this is the accepted date of how old Earth is in the scientific community. So yeah, 4.6 billion years old, okay? So how do we really know that? Think about it. If I go right now and I look at the dirt in my yard or go find a rock at the beach, those weren't the rocks, or that isn't the soil that was around 4.6 billion years ago, okay? The rock cycle is happening. Things are getting weathered and eroded and buried and uplifted and turmoiled for a really long time. So you're not going to find an original rock from 4.6 billion years ago. So how in the world have scientists come up with this date? I shall tell you. So we are not alone in our solar system, right? Meaning there's other planets, right? There's Mars, there's the moon, right? There's other celestial objects, there's meteorites, okay? So our Earth formed about the same time as the solar system. So let's say you're a scientist and you come across a meteorite that has entered through Earth's atmosphere from space. Or you are Neil Armstrong and you went to the moon and you brought back a moon rock. Guess what? Scientists can use radiometric dating to date those objects. They were around when Earth was forming, right? So if you date those objects to be 4.6 billion years old, then Earth must be about 4.6 billion years old, okay? That's what they're using. They're using meteorites and moon rocks and those types of things to date our solar system. And because our solar system is about that old, they've given this estimated date of Earth to be 4.6 billion years old. Okay? So that wraps it up for absolute dating. Remember that we talked about relative dating, saying whether or not something is older or younger than another in comparison, but you're not giving an exact date. Now we've talked about absolute dating, giving an actual numerical value for how old something is, using the processes of radiometric dating and radioactive decay. All right, so have a good day and I will see you all later. Bye.